Oh, hey there, and welcome to your Chapter 9, Lesson 8 notes on systems of linear and quadratic equations. By the end of the day, you'll be able to solve systems of linear and quadratic equations. Remember, a linear equation is something that is in the shape of a line. So a linear equation will always have like y equals mx plus b like that, and it'll be a straight old line just like that. A quadratic equation, on the other hand, quadratic is where you have y equals something times x squared, usually ax squared plus bx plus c. Quadratic is where you have an x squared. Linear is where you've got just an x. Quadratic equations are always in the shape, or the graphs rather, of quadratic equations are always in the shape of a parabola looking like that, or like that. So that's cool too. Okay, now when you have a system of linear and quadratic equations, that's when you have a linear equation and you have a quadratic equation. Their solution is going to be where the lines touch. It's where the graphs intersect. You want to find the point that lies both on the line and on the parabola. So you can have three ways that this happens. The first way is if you have a line going through your parabola like this. If the line goes through your parabola, you have a solution here and you have a solution here. You're going to have two solutions. This is because this line represents all the points that make that equation true. The parabola represents all the points that make this equation true. So it makes sense that where they intersect, those are points that make both of the equations true. So you can have two solutions. You can also have it where the line runs straight through the vertex of the parabola. In that case, it'll just touch the parabola and then keep going. Or you can think of it as like the parabola comes down, 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 bink, tap, and then right back up. Okay, so there's only one point that they have in common. This one point is going to be the one solution. And finally, it is possible that there's no place where they touch. If I have just like some super rando lines like down here, haha, ta-da, they have nothing in common, which is sad, I guess. So we would call this no solution, because there is no point that lies on both graphs. So you can find a system of equations, yes, by graphing, but you can also find it with elimination and with substitution. So let's start out with graphing, and to save you some time, I already graphed them. So I took the quadratic equation, I found its axis of symmetry, and then I plugged in the points around it. And then I took the line and I found, oh hey, this is where if you have y equals mx plus b, here our m is -1, so our slope is -1, and b, our y-intercept, is +2. So with that information, I graphed both of them. So you've got a vertex down here at 1/2, -2 1/4. You've got intercepts here at -1 and 2, and I've got my parabola there. I've also got my line going this way. I started at the y-intercept 2, went down 1/1, down 1/1, down 1/1, just like that. Now remember that the solutions are where the graphs intersect. So there are 2 points here where they intersect. They intersect here, and they intersect there. So they intersect at the point, right here, at the point -2, 4, and they intersect at the point over 2, up 0. That's kind of hard to see, so I'm going to move them. There. Boom, there you have it. So those are the solutions where they both intersect. Now we can check that our solutions are true by plugging them back into both equations. that means taking y equals x squared minus x minus 2 and y equals negative x plus 2. And when you do that, you plug them in here and here. You take each point and plug them in. So say, is it true that 4 equals negative 2 squared minus negative 2 minus 2? Yes, it is. And is it true that 4 equals negative 2 plus 2? Hey, look, also true. Cool. With your other point, you want to check, is that true? Is it true that 0 equals 2 squared minus 2 minus 2? Mm-hmm. And is it true that 0 equals negative 2 plus 2? Mm-hmm. Yay, we did something right. Okay, so to solve by graphing, you just graph both equations. I say both. A system doesn't need to. A system can have infinitely many graphs if you want. Anyway, and you find where they intersect. Where they intersect, that's their solution. Because it's a point that makes both graphs true. You can also solve a system of equations using the elimination method. Oh, you guys. Since this is a system, it should have this curly guy right there. Okay, this is a system. It needs to have a like that. Okay, elimination is where you find where they have something in common and you eliminate it. So I look at these guys and I go, I want to eliminate that. So I'm going to take my first equation, which is my linear equation. I'm going to do nothing with it. I'm just going to rewrite it. Y equals 28x plus 4. But with my second equation, I'm going to make it negative. So it's negative y equals negative x squared plus 39x plus 64. Then I need to actually simplify this. So I'm going to distribute my negative into every term. Give me negative, negative, and a positive. Awesome. Now we can add these up and see what eliminates. I'm just going to rearrange this just a little bit so that the like terms line up. And here we go. 0 on this side is equal to x squared minus 11x minus 60. Cool. Now how do we solve this? We know how to solve this. We can solve it by graphing. By factoring. We're going to look for a number that adds to negative 11 and multiplies to negative 60. And by a number, I mean two numbers. So what's that going to be? How about negative 15 and 4? Now that we have it factored, we can split and solve. So 0 equals x minus 15 and 0 equals x plus 4. After taking the appropriate steps to solve each equation, we get that 15 equals x and negative 4 equals x. Cool, but we're not done. Because remember, that's just the x part. We need points. So we know what happens we need to figure out what happens when x equals 4. We need to figure out what happens when x equals 15. Now, as long as you know what x is, you can take that value of x and plug it back into each equation. I would go with linear because linear equations are easier to work with. So you have y equals 28 times whatever your x is plus 4. I'm taking the linear equation and plugging x in for x right here. When I plug in negative 4, I get that y equals 424. Nope, that's the other one. I lied. When I plugged in 15, I got that y equals 424. When I plugged in negative 4, I got that y equals negative 108. So my points are negative 4, negative 108, and 15, 424. So elimination method is when you multiply equations and then you add or subtract to knock out a variable. That's one way to get rid of your variable. Another way to get rid of your variable is with substitution. If you notice that y equals this expression and y also equals this expression, I'm going to take the 4 minus x and I'm going to substitute him in for this y right here. That gives me 4 minus x equals x squared minus 6x plus 10. I don't know how to solve that, but I do know how to solve when it's equal to 0. So to get this equal to 0, I'm going to add x to both sides, which gives me 4 equals x squared minus 5x plus 10. I don't know how to solve that, but I know how to solve when a quadratic's equal to 0. So to get there, I'm going to subtract 4 to both sides. And that'll give me that 0 equals x squared plus 5, sorry, not plus 5x, minus 5x plus 6. I know how to solve that. I'm going to factor it, and I'm going to look for two numbers that add to negative 5 and that multiply to 6. Those numbers are negative 3 and positive. No. What did I do wrong? Negative 3 and negative 2. That's it. Ha ha ha. Okay. Hey, I know how to solve this. This is a split and solve question. So we split and we set each of these factors equal to 0. So 0 is equal to x minus 3, 0 is equal to x minus 2. This gives us that x equals 3 and x equals 2. Cool. But we're not done. You plug them both back in to the linear equation because the linear equation is easier. So if you have x equals 2 and x equals 3, you're going to plug those in to y equals 4 minus whatever your x value is. So if x equals 2, y is 2. If x equals 3, y is 1. So the solution to this system is 2, 2, and 3, 1. There you have it. You can solve systems of equations using the methods that we learned earlier, with substitution, with elimination, and with graphing. It doesn't matter that they're two different types of equations. But be careful, there won't always be a solution. Sometimes you might just have the one, and that's okay, as long as you have a fantastic time on your homework.